All right. Hey guys. Um, Welcome to Crafting Interpreters and Rust again. It's Halloween. Uh, and we are working on making the variable resolution pass from chapter 11. So I'll bring up chapter 11. Resolving and binding. All right. So the big idea is that we are making an additional pass over the AST, which runs before we interpret the code. And it's called the resolver in here. Um, that's a sort of generic sounding name to me, so I'll probably call it like variable resolver. And what it's supposed to produce at the end is um, this map from an expression to how deep the into the list of scopes you should look to find the variable representing that expression called locals. So what we're going to make is a function that takes a program, meaning an AST, and then outputs that map. And then we will need that map in order to evaluate a program later. So let me see what we have. Um, I did some stuff last time. I don't think any of it was really important. We were kind of just looking at the book to see what we would need to change. All right, so resolution distance. So we still haven't fully decided whether to think of this as a pass, like that function that I just mentioned that produces this hash map, or an additional pass which fills in some information on the AST. Um, Before I go implement either of them, do you have any thoughts about which one is better?
I think it makes sense to have it in AST. The book uses arbitrary expression as a key, but it
Yeah,
doesn't really make much sense.
I agree.
Only the variables
Yeah, because
have this property.
all right. So basically you're saying that this change that we made here is how we want to encode
Yeah,
it. Okay.
yeah, it makes to me.
All right. I think
I
that
remember we had a problem with broken test. Did you had a chance to look at Insta?
no, we'll do that now. Insta was the sort of like snapshot
Snapshot testing, yes.
snapshot testing.
So right now we have to manually write expected value, but in case of Insta, you just run this command line tool.
Is there
Uh,
when do you have like a separate command that you run to populate the snapshots? How does it work?
so the idea is when you run test first time, they fail or something like that. And then there is a tool to resolve the difference.
Okay. Similar? No, that's just what they use for diffing. Okay. Yeah, I'll try it. I think first I want to figure out just sort of what we're doing here though. So
Sure.
the I think the thing that they encode in locals is not actually like the resolution distance, as in like how far up from the current scope you need to go. It's like the absolute depth. So like just from the top scope, how many scopes down was it when you encountered it? So I think I'm going to call the thing that we encode resolution depth and not distance. Right. Okay. No, I actually want to call it resolution depth in the enum. Okay. So now is it gonna? Yep. Of course. All right. Okay. And then this also simplifies this because we're not recording how many leaps back it is. We're just recording the absolute number. So it's just get resolution depth. Okay. And then I don't know what this is. A debug fingerprint thing. All right. Doesn't matter. All right. So now, or do we compile yet? No, we don't. Did you want to just sort of scrap these tests and then put insta in and
Yes, something like that.
Okay, that's fine.
It will be used in the debug instance.
Sure. Okay. I assume that's the right one. Let's see.
Yeah.
Great. Their example is so we don't necessarily need to use it. We're just going to insta assert instead of regular assert. Okay, so let's try one of them that's failing here. Like this one. Yeah, this is a perfect example, right? Because we gave up on trying to find the exact value. So we're gonna do insta assert something, right? Debug snapshot. We broke Rust analyzer. And then what do we actually put in here? The thing that we're trying to
you just put
yeah.
the new value and it will be reading the expected file.
Okay. Okay, and all these examples broke because
What's more, we can insta assert the whole environment.
What do you mean?
We can insta assert the whole environment.
Oh, sure, that's fine. The dereference though, right?
No.
No?
Yeah,
Okay.
and you can get rid of the next line.
Okay. So, and that'll generally apply, I guess. That does make the test sort of less expressive, right? Like where did the debug snapshots actually get?
It will be stored in a file.
Okay.
I'll try running the test. This test specifically.
This still won't compile.
It doesn't compile.
The problem is just that we need the resolution depth in order to get something now. Um, right. Okay. One thing here is I think there might have still been a case where um he uses the old resolution method, maybe for globals or something. Okay. No, I think yeah. Um, mhm. Gonna have like a ton of mentions. When resolving a variable, if we can't find it, we assume it must be global. Okay, so the answer is no. He doesn't have any case where he uses the old method. So there's no point having like a get without that resolution depth. Like you always need the resolution depth. Okay. So, I mean, I guess I'm just gonna do this again. Mm, why do we have two of these? All right. Guess we wanted to assert two different things. All right. Okay. Still complaining about something. That one. Okay. You compile. Oops. You compile. Yep. But you failed tests, which we expected because you're taking a snapshot.
Yeah, and it shows the new environment, and there is a command cargo inst review you can run.
Mhm. All right. So I'm guessing what this does is um, I will manually review each of these to make sure they look okay
Yeah.
and then approve or not. All right. So do I need to cargo install Insta to get the
Possibly. You can type cargo inst review if it complains, and yes, you need to install it.
yeah, that's what I did.
Okay. Yeah, you need to install it.
No binaries. Okay, I added the library.
I think the accompanying binary should be mentioned on the GitHub page. Let me see. Uh,
Companion cargo Insta tool.
Installation.
I
Yeah,
think it's going to be
companion.
called cargo Insta. Yeah. There we go. All right. So how do I tell?
A FASEPT R project.
I was hoping that it would show the code next to this, but whatever. All right, so this has, this is line 98. I think so.
Yeah, accept. One oh seven.
Wasn't this the thing? This is the thing that was supposed to break, right? No, no, wait. Scope closure.
Well, we run interpret, but we ignore the result. Maybe if you add an roundup, it will panic. Line 106.
No, I think this is correct. Because yeah, that's not what I'm saying. I'm saying that this is the, I thought for a second that this is the one that's supposed to fail that we're resolving by doing the chapter 11 thing, but I don't think that's the case. I think it's normal. So this is fine.
Okay.
Why were those the only two ones? It stopped on the first one that failed. Panicked. Okay. Yeah, is that what you're saying?
Yeah, no. We have to do that. We need to fix.
Why is it panicking here? All right, 247.
So now it tries to find the result of the resolution depth, but we haven't implemented it yet.
Great. Okay, so this is the one that's supposed to fail.
Yep.
Gotcha. All right, so let's implement resolution depth. All right. All right. So what are we exactly doing here? We definitely take an AST. And then
By mutable reference, I think.
um, fills in the resolution depth for all identifier nodes in the AS in the program. Okay. So we're going to do recursive descent again, but it's going to be simpler. So here's where like the visitor pattern is actually a little bit useful because it keeps the same recursive structure. And you just have to change the visit methods, but that's okay. Instead, I'll just copy paste. Hmm. So somehow we haven't actually implemented evaluate for the entire program. That's interesting. So what are we actually doing in here?
We have it false states.
Interpret. Okay, So
Uh,
we're interpreting as we're going directly to the sequence of declarations thing instead of the entire program. I think I'll fix that up real quick. Program is just a bunch of declarations, so you can just wrap it.
we use the environment for tests. Maybe evaluate should return the environment.
That's fine. Yeah, that's fine.
You have the whole program instead of AST. So it's already parsed.
Okay.
So that would be program dot what's body? Yeah.
That doesn't seem right. Program dot to zero. What do we do?
No, it's but
It's
it's the
body.
name struct body.
Okay. There we go. And then question mark, I guess, because this is a result also. Yeah. Okay. So I guess we can still use an env stack, but just not do anything aside from make the variables. What do you think? Like what bookkeeping structure should we use for figuring out or just keeping track of which depth things are at?
As far as I understand, we descending from the top to the bottom, and we keep a hash map from variable to depth. And once we encounter a variable, we insert
Hmm.
the new
Okay,
value or something.
so the only state we need to keep throughout that traversal, I think, is the depth, right? Like the
Yeah.
current depth. Okay, cool.
Well, current depth and depth for each variable. Is it?
Well, we're gonna
Okay.
we're going to mutate the AST to record the depth for each variable, right?
Okay.
Uh, wait, do you need to look up the depth for previous variables while you're traversing in the
I'm
resolution
not
class?
sure. I missed that chapter.
Okay. It was pretty complicated. We can see if he needs to do that. I think the only thing that he's doing is he like most of the node types he just recursively calls resolve and does nothing. And then the ones where you actually declare stuff, he uses some helper function which eventually figures out. I think the helper function probably refers to the state. Mm. Oh no. Okay. He needs he needs an entire um stack of environments, just like we do. Because what he does is whenever he decides to actually figure out what depth things are at, he starts from the innermost scope and then goes outward. So he needs that data structure to be created so that he can iterate over it. So I think that we need an env stack in this one also.
Yeah, yeah.
And then here we need like mutable references to pretty much everything. Just because we're doing it in place. I think so. Because like, yeah, we're going to use recursive descent, and then we could encounter an expression that we need to modify at any point. So we need to propagate the mutability of this thing down. Okay. All right. So pretty much, I think no matter. Oh wait, no, the declarations actually matter, don't they? Declarations are when we need to like go resolve. Yeah, because we're doing state.define. Okay. It's tricky. Yeah. Let me see what his visitors are. All right. So you visit a block. Blocks don't matter. You just call resolve. Variable declaration. Okay. But that's not the same thing as the variable expression, which is a use of the variable. I don't know. All right. Functions both by names and introduce a scope. Trying to figure out why he needs a different thing for functions. You need to do params specifically. All right. Let me see what these helper functions are. That would help me. Um, okay. So here you're doing an adding to the top scope, I guess. Okay. What's the difference between that and declare? Is that not the same function?
Well, I imagine why one just says that there is such a variable and not assigning it a name, and second one gives it a name,
Oh, yep. The only difference is that.
the value.
So he's his scope here keeps track of the um name and whether it has a value, I guess. See, why does he need to do that? All right. Okay. Lexical scopes nest in both the interpreter and the resolver. Yep. So we're doing that. They behave like a stack. So we're doing that. We're making this end stack and passing it down. But what are the booleans here? Okay. Values are booleans for a reason I'll explain soon. Um, okay, let's see about booleans. Is it just for this shadow detection thing? No, because he doesn't care about whether it's true or false in this little check here. So, hmm. Okay. When does he check? When does he check the true or falseness? I don't really get why he needs to do that separately. Okay. Yeah, this is sort of what I was looking for. Okay, so a function variable declaration adds a new variable to the current scope. Function declaration introduces a new scope for its body. Okay, which we don't need to do here. Block statement introduces new scope. Variable and assignment expressions need to have their variables resolved. Okay. Okay. So interestingly, the function declaration here, we don't actually add like a new scope here. When do we do a new scope? I guess right now we do it when the function's called. Like here we just define the function in the current scope, but we don't make the new scope. So he's saying that we need to do that on the declaration of the function instead of the use of the function. All right. So I'm going to say all right. Okay, a variable declaration adds a new variable to the current scope. So that is what this will do. Except I think I think I'm going to make a different structure here because n stack is basically the same except for the values are not, there are like always booleans for him. I still don't know why he needs a boolean value. I was just looking through the book. So let me make a slightly different one. Hmm. So this maybe I should just put this in a different file and we can have a locally scoped environment type. Okay. Um, so here, environment just has bools. And then I don't know why this whole thing's like grayed out. Maybe I'm missing something. Maybe it's because it's not added to here. Yeah, there we go. All right. Then what are you complaining about here? You don't know what that is. That's actually fine because we're not going to use name. We're going to have bools. Or we're not going to use
We are going to use name, we're not going to use values.
Yeah, I misspoke. All right, so this is I guess value. I'll just remove that. This is bool. And then, so declare. Yeah, what did he have? He had declare and define, and then, right? Declare. Declare was false, and then define was true. I want to know why, but we will. And I don't think we need reassignment. Let me see. Discord. Okay. I think this is just talking about how to use it once you've gotten the resolution set up. Yeah. Okay. So I don't think we're going to be getting stuff. Are we going to be removing stuff? I don't think so. We might still have this. And then define doesn't need that. All right. We still need this. I think we're good. Okay. I think we're going to be okay with that. So I need to know what a program is. Probably will need to know what some of these are, but I'll remove them at the end. All right. You don't know what values are still. It's okay. So normal declaration, that. Okay. And then here's the recursive case where we resolve statements. Okay. Okay. Sorry about that. Okay, so mute statement. And then state is another env stack, but like this funky type. And then we need to mute it. Okay. Cannot, so this is, why is this not mutable? Do I need to like do this kind of thing? No. Okay. So this, yeah.
You shouldn't have to specify the mute, I think. No, on line 64. Looks a bit strange in there.
So, okay, this is a mutable reference to this declaration already. Okay. So
Okay, so statement is
it's a box right now.
I think you can do something like dot mute or some
Ref mute.
there is method on box. There should be method on box to give you mutable reference. Let's see. Should be. Okay, you can get the pointer.
Do I need to like? Okay, so what is mutable here? This is a mutable reference to the box. Shouldn't it be? Shouldn't the mutability be on the inside? So I want to mutate statement.
We cannot have it because a box is what we have.
Okay. Well, this is sort of the tricky part about having it be in the AST, right? Like you have to pass the mutability down all over the place.
Oh, you have a mutability, you just have box. I don't think I had to. Okay. Box. Yeah, just dot as mute. As mute. And get rid of this.
Okay. So that's, let me look at the type signature here.
It goes through the as mute trait.
Okay. Okay, sure. So it's just the particular, is anything else allowed to do this?
A lot of things, if you look for documentation of as mute trait,
Mhm.
a lot of things is implementing it.
Yeah.
I guess you need to open it in Rust doc and scroll down to sections of implementers.
Yeah. It's, I guess like, okay. The fact that, here's what I don't get for like traits that are made by Rust.
Yeah.
Is there magic here? Or is it just like there's some unsafe somewhere? Like how did it
There
work?
is no magic. There is this trait and it's implemented for a bunch of types.
Is there anything to the implementation aside from just asserting that Box implements as mute? Or do you just kind of
There is no assertions. So if you open the Rust documentation for Box, so yeah, first one. Now scroll down to asref, as mute. Then there is a source and simply implements it. There is no magic.
okay, okay. So, but if I had used this magical expression,
It would probably work as well.
okay, to just like, yeah, bypass as mute. Yeah, because there's nothing special
I just
here.
don't like to use a lot of stars. It's
Yeah, me
that's
neither. I'm just wondering, I'm just trying to figure out, in general, this is still legal syntax. It's just that there's
yeah.
a cleaner way with the trait.
Well, as mute will handle multiple levels of references.
Mhm.
And with those stars, you have to specify it yourself.
Okay. Yeah, this is fine. All right. So pass it down in here. And then I'll yet again copy the recursive structure. So interpret statement. Um, we basically just match on it. And I think we probably don't care about most types of statements. Most of them are just going to recurse down. So let's get the list in here. All right. Um, let's see, which ones do we need to do something special on? So I think these ones. Yeah, a variable declaration that was in our list, a block that was in our list because it modifies the scopes. Then anything else I don't think we care about, right? Let's see. Where's that list again? There we go. All right, so blocks, function declarations, variable declarations, and variable and assignment expressions. All right, which will happen when we get down to expressions here. Okay. But we don't need to do anything about special with expressions at this level. We just recurse. Okay. So getting rid of these, getting rid of these, and then the default case will be to recurse, I guess. Or wait, no. In order to know how to recurse, you need to specify which type of thing you're dealing with, I guess. So yeah, I can't actually do that. I have to say resolve Expr. And then define that. And then everywhere we interpret statement, we're instead going to resolve statement. Okay. Is there anything else saying interpret? Yes. Resolve decals. Okay, no more. Okay. So let's fix the stuff to do with state.define, right? Because we don't need the value in here. Define global. I don't think we actually need this anymore. Yeah, we don't need that. Okay. State.define. Okay, that's everything. And then we need to keep going. Ah, this. Oh, right. Okay. So for stuff like that, for control flow, I think we need to take both branches, right? Because we're not actually going to do anything. We're just going to recurse over the AST and figure out the variable declarations. All right. So we're not going to do any sort of short circuiting or anything. We're just going to resolve both. Okay. And then similarly here, we don't need
we probably need to go through condition as well. Resolve expression.
here. Yeah. Yeah, we do. You're saying we just don't need that?
Yep, we don't need resolve, we just need to correct it.
Yeah, okay. And same here, we're just going to call it like that. Okay. And then, okay, so a for statement. No, yeah, we desugared this into a while statement. I guess we can just keep doing that. That's fine. But in order to know that, it needs to import some more parser types or something. Like it doesn't know what these are. Let's see. Okay. I'm sure there's like a million things wrong with this, but somehow there's an extra, or there's a missing things. Yeah, there we go. Okay. This is an ugly place to stop. I guess before I stop, I'm gonna define resolve expr also. So keep going down. it'll take a mutable reference to an expression and the state, which is this env stack thing, and then we will copy the structure for eval expr. And most of these will be irrelevant, I think. In eval expr, okay. The only time that we would call recursively is grouping, right? Or no, we do it all over the place. Okay. That's a shame. Okay. You. Okay. Well, it's pretty ugly. So it's expression identifier, I think, does something because we need to act. This is where we need to actually fill the resolution depth, I guess. Okay. These we don't care. I don't care unless it calls something recursively. Okay. Um, and yep, I don't care about the result here. I think we just need to, for expression binary, we just resolve the left and then we resolve the right. Okay, member assign, actually, we do care about because it's an assignment. So modify state. I don't know if we care about call. We do because it's recursive. Okay. Well, this is a fun place to leave it, but we'll get. Okay, so next time we'll try to clean this up and make the recursion work correctly for resolution. But this is a decent start. So any questions about what we just did? So some people joined late. Okay.
Sorry, could you give a if this is gonna take too much, I don't want to take a lot of time, but if you can give like a real brief explanation of how the environment stack will work as you kind of say you're kind of three scopes in and you reference a global variable, how would
Yeah.
the stack operate?
So first of all, we're changing the focus of chapter 11 is changing how the stack works. But I will show you how it worked before. So before, an environment stack is just a vector of environments, and an environment is maps the variable name to the runtime value.
Okay.
And because this is a dynamically typed language, it's always the same type here, right? A value is like one of the possible things that it can be at runtime. Okay. So that's what we're maintaining. Whenever you so like when you define variables and assign to them and stuff, that modifies the structure. And then later when you look up a structure or when you look up a variable, this is actually the new way, but this is sort of the old way.
Mhm.
So you want to know what value a particular variable name has. What you do is you start from the innermost scope. So this is in reverse order, right?
Got it.
You're iterating in reverse order over the vector. And then if it's defined in that scope, then you return that. Otherwise, you keep going. So for a global variable, like you were asking, it would only be defined in the topmost scope. So
Right.
like the first thing. So the global variables would be like the most expensive to access, right? Because you would fail to find them in all of the inner.
Sure. Sure. So is the pop and push, so the push method I think is pretty self-explanatory. The pop method, that's when you're no longer going to use a scope.
Mm-hmm. So
Okay, got it.
the only time that we push and pop is for blocks. I think we're going to have to change it to oh wait, no, maybe we do it for functions. No. We only do it for blocks because function definitions contain blocks. So
Mhm.
yeah. So if we have like this kind of thing, new scope, var x equals 6, right?
Mhm.
First we put x is 5 in element 0.
Mhm.
So here's the end of stack, right? X is 5, and then we push an environment when we enter this inner scope. So we have x5 and then empty. And then we reach this variable declaration. So we go x5, x6. Then if I were to go like print x in here, it would, when looking up what x is, it would reach this one first.
Got it.
Then
Got
we
it.
exit that and then pop the last one. So now this entire thing doesn't exist.
Right. So if you print X again, it'll be 5 this time. Very cool.
Yeah.
Thank you. Thank you for that.
Yeah. So that's how it was working. Now we're changing it to work better or work in a more well-defined way, like in the static scoping way that he described in chapter 11. And unfortunately, in order to do that, we need to introduce an entirely new pass over the AST, which maintains a different data structure. It will be similar to this one, except we don't care about what values things have. We just care about which things are defined.
Okay.
And what we're going to do with that is whenever we use a variable, we record like some good definition of how deep it was in this stack. So this all happens before we evaluate anything in the real program. This is like a pre-evaluation pass. But what will happen is we will modify the AST to say like, when you reach this exact node representing X, the AST will say print the X at depth 2, right? So it'll contain both the name of the variable and the depth that we got from this previous pass. And what that means, among other things, well, first of all, it changes the semantics of the language to be more correct. But also it means that we can, when we look up a variable, we don't need to do that starting from the innermost scope and going out thing, because we already did a pass to know exactly which scope it was at. So we just index into that vector to see what, like at the resolution depth that we know is correct. Yeah. So that's what we're doing. And right now we're making the resolver pass, which is like this structure is this thing. And then all of this recursive nonsense is the functions that are going to maintain the structure.
Got it.
All right. Hope that was a useful explanation.
Yeah, no, definitely. Thank you.
Cool. All right. I will stop there. Happy Halloween, guys, and I will see you next time.